Okay, today we are starting with transformations. The transformations we are learning today and tomorrow we will be able to use these same types of transformations to other types of functions like quadratic, square root, cubic functions. So what we're learning the next 2 days is really important because it's going to be probably 3 to 4 more units of this entire semester. So what we're learning today is just setting up the foundation for several other units to come. So make sure you're here today and tomorrow. Okay, so looking at the top, we are given this function. F of x equals absolute value of x. So those 2 vertical bars mean absolute value. And I want you to label this as the parent function. Now the first thing we'll have to do is we will have to complete this table. So to complete this table, we're going to take all of these x values and substitute them in for x into that equation. So for this first one, we'll have to find the absolute value of -3. Now you have learned what absolute value is. You learned that back in Algebra 1, but it's been a while. So as a refresher, absolute value means distance from 0. So if this is my number line, here is 0, here's -1, here's -2, here's -3. So if I'm looking for the absolute value of -3, I am looking for the distance from -3 to 0. So what is the distance? How many units apart are they on the number line?
2. -3.
Here's 1, here's 2, here's 3. They are 3 units apart. So when you take the absolute value, your answer is going to always be positive. Because if you're talking about distance from 0, distance is always positive. It's never negative. Now the next one, the absolute value of -2. What is its distance from 0? 2 units. Absolute value of -1 would be 1. The absolute value of 0, 0. The absolute value of 1 is, the absolute value of 2 is 2. And the absolute value of 3 is 3. So now we have completed the table. Now we will need to plot those points on the graph. So the first ordered pair is from the first row. We have -3, 3. So find -3, go up to 3. Then we have -2, 2. Then we have -1, 1. Then we have 0, 0. 1, 1. 2, 2. And 3, 3. And if you look, what shape do those points make? They make a V shape. So absolute value is always going to be a V shape. If you don't get a V shape, that means you either did the math wrong or you plotted the point incorrectly. So connect those points to make your V. And you have to have the arrow showing it keeps going up. So put the arrow showing it keeps going up. Now we have on this one we only have 2 questions to fill out. Only the domain and range. Now back in Algebra 1, we did talk about domain and range. And hopefully you remember that domain are the x values and range are the y values. Now, you probably were taught somehow to try to remember this. Your teacher probably said that alphabetically D comes before R and X comes before Y. So domain is always X, range is always Y. Now for our purposes, we are going to be writing our answers using interval notation. For interval notation, we will have 2 numbers in our answer. We will have the smaller answer, and I'm going to call the smaller answer our lower boundary. we will have our larger answer, and we're going to call that our upper boundary. So you will have two numbers ordered from least to greatest, and they will be separated with a comma in the middle. Now for interval notation, we have to mark off these boundaries with using either a parenthesis or a square bracket. And I will tell you how do you know when to use either one. So that's what our intervals will be looking like today. We'll have a small number, comma, the larger number, and then they will be marked off with either a parenthesis or a square bracket. So that's what interval notation looks like. So we're switching over into interval notation because those of you moving on to calculus, you'll need not calculus, but to pre-cal and then calculus. But if you are moving to pre-cal, you'll need to know this interval notation. Okay, so for domain, domain are the x values. Okay, for the domain are the x values. So if I look at my last point, is this where my x values start at -3? Is that the starting one? No, it goes past it. It really starts over here. What does this arrow mean? It keeps going, not to infinity, because on the left side of 0 would be
Beyond.
negative infinity. Negative infinity. So that is my lower boundary. My x's go from negative infinity. And look at the other side, and what does this arrow on the right side mean? It keeps going to positive infinity. So our domain is from negative infinity to positive infinity. It keeps going to the left, it keeps going to the right. Now I have to decide, do I put parentheses around them or a square bracket? So here's the rule. If you can touch it, it gets a square bracket. If you can't touch it, it gets a parenthesis. So looking at your graph, will your graph ever touch negative infinity?
Yes.
Can you touch negative infinity? Will you ever reach it?
No.
No. So if you will not have a point there, it's going to be a parenthesis. You can't touch infinity or negative infinity, so they'll both get a parenthesis. So you'll never get to infinity. You will not have points there, so put parentheses. So if you can't touch it, put a parenthesis. Now the range. Range are the y values. So if you look at your vertex, this point right here at the bottom of the V is called the vertex. What is the y value at that vertex? 0. So the y values go from 0 all the way up to what? Infinity. It keeps going up. So it's going up to positive infinity. Now when you write your interval notation, the smaller number always goes first. So it's going to be 0, comma, infinity. Now can I touch infinity? No. So the infinity gets a parenthesis. Now looking at my graph, do I have a point right here at 0?
Yep.
Yes. So I need to include that in my answer. So if you have a point there, it gets a square bracket. So 0 gets a square bracket because we have a point at 0. Infinity gets a parenthesis because we cannot ever reach infinity. Now again, with interval notation, make sure the smallest number is first, the larger number is last. And looking at our parent function, I do want you to notice that the parent function passes through the origin, and it goes up 1, over 1, up 1, over 1. So keep that picture in mind. We're going to be using that when we're trying to distinguish what types of transformations occur. So looking at number 1. Number 1, we need to complete the tables and draw the graphs of the following transformations. So number 1, the equation is y equals the absolute value of x plus 2. So we are going to take the -5, substitute it for x. So inside the absolute value, we'll have -5 plus 2. Now these first few, I'm going to write out the math so you can see where our answers are coming from. For the next one, it's going to be absolute value of -4 plus 2. And then we'll have the absolute value of negative 3 plus 2. The absolute value of negative 2 plus 2. The absolute value of negative 1 plus 2. The absolute value of 0 plus 2. And the absolute value of 1 plus 2. Now, handoff, order of operations. You work inside your grouping symbols first. So work inside the absolute value. So inside our absolute value, looking at this first one, what is negative 5 plus 2?
Negative 3.
Negative 3. So work inside the grouping symbol first. Then take your absolute value. And what's the absolute value of negative 3? 3. The distance from 0 would be 3 units. Next one, inside the grouping symbol, what's negative 4 plus 2?
Negative 2.
Negative 2. And what's the absolute value of negative 2? 2. Next one was negative 3 plus 2. Negative 1. And what's the absolute value of negative 1? 1. So the next one was negative 2 plus 2. 0. And what's the absolute value of 0? 0. The next one was negative 1 plus 2. 1. And what's the absolute value of 1? 1. Next one was 0 plus 2. 2. What's the absolute value of 2? 2. And the last one, 1 plus 2 is? 3. The absolute value of 3 is? 3. Now we need to plot all of those points. So plot those points. The first point would be negative 5, 3. Negative 4, 2. Negative 3, 1. Negative 2, 0. Negative 1, 1. 0, 2. And 1, 3. And if we did the math correctly, and if we graph the points correctly, you should always have a V for absolute values. And make your V. And make sure you put arrows showing it keeps going up. Domain, what does domain mean? X, what do these arrows mean? Keeps going, so it keeps going to what number on the left? Negative infinity, and it keeps going to what number on the right? Positive infinity. Can I touch infinity? No, so both of these get parentheses. Now for the range. Range, what does range mean? The Y value. So looking at the vertex, what is the Y value right here at the vertex? Be careful, what's the Y value here? Negative 2 is the X value, the Y value is 0, and it goes all the way up to what number? Infinity. What number goes first, 0 or infinity?
0.
0, so it's going to be 0, comma, infinity. Can I touch that 0? Do I have a point at 0?
Yep.
Yes, so put a square bracket. Can I touch infinity? No, so infinity gets a parenthesis. And the last question was to know, how does the graph change? So we need to compare this to the parent function. So if I go back to the parent function, remember that the parent function has its vertex at the origin. So keep that in mind. If I look back at number 1, instead of the point for the vertex being at the origin, which way did it move? To the left, how many? 2 units. So we need to say it translates left 2 units. So it translates left to units. Okay, next one, number 2. Again, we are going to work inside the grouping symbol first. So instead of x, we're going to start with a -1. So this would be the absolute value of -1 minus 2, absolute value of 0 minus 2, absolute value of 1 minus 2, absolute value of 2 minus 2, absolute value of 3 minus 2, absolute value of 4 minus 2, and absolute value of 5 minus 2. Now again, I'm just writing out the math just for the first piece so you can see where the answers are coming from. So again, order of operations, work inside the grouping symbol first. So looking at the first one, what is -1 minus 2? -3. And what is the absolute value of -3? Positive 3. Distance from 0 is always positive. Next one, what is 0 minus 2? -2. What's the absolute value of -2? 2. What is 1 minus 2? -1. And what's the absolute value of -1? 1. Next one, what is 2 minus 2? 0. What's the absolute value of 0? 0. Next one, what is 3 minus 2? 1. And the absolute value of 1? 1. For the next one, what is 4 minus 2? And what's the absolute value of 2? And 5 minus 2? 3. Absolute value of 3 is 3. Now we need to plot those points from the table. Okay, plotting these points, we have -1 goes up to 3, 0 goes up to 2, then we have 1, 1, 2, 0, 3, 1, 4, 2, and 5, 3. And if we did the math correctly, and if we graph the points correctly, you should always see a V shape for absolute value. So go ahead and connect the points. Make your right arm with an arrow pointing up, and to make your left arm with an arrow pointing up. That first question is asking us for the domain. What does domain mean? The x value. What do these arrows mean? It keeps going to -infinity and positive infinity. Can we touch -infinity or positive infinity? No, so both of these get parentheses. What does range mean? The y value. So if you look at your vertex, what is the y value at the vertex? 0. So my y values go from 0 all the way up to positive infinity. When I write my interval, what goes first? 0, comma, infinity. And do we have a point at 0? Yes. So does 0 get a parenthesis or a square bracket?
Square.
A square bracket. And the infinity gets what? A parenthesis. Now the last question is asking us, how does this graph change compared to the parent function? Remember that the parent function has its vertex right here at the origin. But is the vertex at the origin?
No.
No. Which way did that vertex move? And move to the right how many units? 2. So we need to say translate right 2 units. So it translates right 2 units. Next one, number 3. We have y equals the absolute value of x, and then we have a plus 2. So again, do the grouping symbol first, and then add 2. Now this one I'm not going to write everything out, we'll just do it visually. So if I put a negative 3 right here, what is the absolute value of negative 3? 3. What is 3 plus 2?
5.
5. If I put a negative 2 here, what's the absolute value of negative 2? And what's 2 plus 2? 4. If I put a negative 1, what's the absolute value of negative 1? And 1 plus 2? 3. If I put in a 0 for x, what's the absolute value of 0? And 0 plus 2? 2. If I put a 1, what's the absolute value of 1? And 1 plus 2? 3. If I put a 2, what's the absolute value of 2? And 2 plus 2 is 4. If I put in a 3, what's the absolute value of 3? And 3 plus 2? 5. Now we need to plot those points. So we're going to have negative 3, 5, negative 2, 4, negative 1, 3, 0 goes up to 2, 1 goes up to 3, 2 goes up to 4, 3 goes up to 5. And if we did the math correctly, and if we plotted the points correctly, what shape should absolute value always look like on a graph? A V shape. So connect your points to make your V. And make sure you put the arrow showing it keeps going up. Now for the domain, let's look all the way back to the beginning. What was the domain for the parent function? Negative infinity to positive infinity. Look at number 1. What was the domain for number 1? What was the domain for number 1? Same thing. Negative infinity to positive infinity. Look at number 2. What's the domain for number 2? Same thing. So what is the domain for all absolute values? Negative infinity to positive infinity, because all of these will keep going to the left and keep going to the right. So the domain for every single absolute value function is always negative infinity to positive infinity. Now range. What does the range mean? The y value. So look at your vertex. What's the y value at your vertex? 2, and the y go all the way up to infinity. So the range would be 2, comma, infinity. Do I have a point at 2? Yes, so 2 gets a square bracket. Do I have a point at infinity? No, so infinity gets a parenthesis. Now, how does this one compare to the parent function? It goes up how many? 2 units. So we need to say translate up 2 units. Translate up 2 units. Okay, I want you to do number 4. Okay, the grouping symbols first. If I put in -3 for x, what's the absolute value of -3? 3, and what is 3 minus 2? 1. So the first answer was 1. If I put in -2 for x, what's the absolute value of -2? 2, and what's 2 minus 2? 0. If I put in -1 for x, what's the absolute value of -1? And 1 minus 2? -1. If I put in 0 for x, what's the absolute value of 0? And 0 minus 2? -2. And if I put a 1, what's the absolute value of 1? And 1 minus 2? -1. Okay, if I put in a 2 for x, what's the absolute value of 2? And 2 minus 2 is? 0. And for that last one, if I put in 3 for x, what's the absolute value of 3? And 3 minus 2 is 1. Those of you just joining us, absolute value means distance from 0. Okay, so now, I'm going to go ahead and put the domain. What's the domain for this one without even graphing it? Negative infinity to positive infinity. Can I touch infinity? No, so the infinities get parentheses. And those of you who just joined us again, those need to be written from least to greatest. So negative infinity is smaller, it goes first. Infinity is largest, so it goes last. Now graph those points. So -3 goes up to 1. -2 stays at 0. -1, -1. 0, -2. 1, -1. 2 zeros. And 3 1s. And if you did the math correctly, and if you plotted the points correctly, it should have made a V shape. So make your V. And put arrows showing it keeps going up. And the range, what does range mean?
The Y.
The Y value, so what's the bottom line value? -2. And it goes from -2 all the way up to infinity. Now, which one goes first, -2 or infinity? -2, comma, infinity. Do we have a point down here at -2? Yes, we do. Right here at the vertex, we have a point at -2, so -2 gets a square bracket. And can I touch infinity?
No.
No, so infinity gets the parentheses. Now, how does this one change? Remember, we are comparing it to our parent function. So the parent function has its vertex at 0. Does problem number 4 have its vertex at 0?
No.
No. So which way does the vertex move?
Down 2 units.
It moves down 2 units. So we need to say translate down 2 units. So it translates down 2 units. Okay, on the last page, number 5. Now, this means 2 times the absolute value of x. So we need to do 2 times the absolute value of -3. So we need to make sure we work inside the grouping symbol first. So grouping symbol first, and then multiply that answer by 2. So what's the absolute value of -3? 3, and 3 times 2 is 6. What's the absolute value of -2? And 2 times 2? 4. What's the absolute value of -1? And 1 times 2? 2. What's the absolute value of 0? And 0 times 2? 0. Absolute value of 1. And 1 times 2? 2. What's the absolute value of 2? And 2 times 2? 4. What's the absolute value of 3? And 3 times 2? 6. I can go ahead and write the domain. What's the domain for all absolute values? Negative infinity to positive infinity. Every time. Now plot your point. -3 goes all the way to the top to 6. -2 goes up to 4. -1 goes up to 2. 0, 0. 1 goes up to 2. 2 goes up to 4. 3 goes up to 6. And if we did the math correctly and plotted our points correctly, it should have made a V shape. Now the parent, well, first of all, I forgot the range. What does range mean? The y value. So if you look at your vertex, what is the y value down here at the bottom?
0.
0, and the y's go all the way to, what's the y value at the top? Infinity, because those arrows means it keeps going. So right stems from least to greatest, so it would be 0, comma, infinity. And do we have a point at 0? Yes. So 0 gives a square bracket. Can we touch infinity? No, so infinity gets a parenthesis. Now, how does this one compare to the parent function? Did the vertex move?
No.
No, but something else changed, because on the parent function, to get to the next point, we go up 1 over 1, up 1 over 1. Is that what they're doing here?
No.
No, how much are they going up?
2.
They're going up 2 over 1. Up 2 over 1, up 2 over 1. So we call that a stretch. So for this one, number 5, it would stretch by a factor of 2. So this is called a stretch, and you have to say how much is stretched. So it's stretched by a factor of 2. And we call it a factor because it was being multiplied by 2. The factors are things that were multiplied. Okay, the next one. Now we have a 1/2 out front. So take the absolute value first, then multiply it by a half. If I put a -3 right here, what's the absolute value of -3? 3. And what's half of 3? Half of 3 is 1/2. 1.5. I put a -2 right there. What's the absolute value of -2? 2. And what's half of 2? 1. If I put a -1, what is the absolute value of -1? 1. And half of 1? 0.5. If I put in 0, what's the absolute value of 0? 0 and half of 0 is 0. If I put a 1, what's the absolute value of 1? 1. And what's half of 1? 0.5. And if I put a 2 here, what's the absolute value of 2? 2 and half of 2 is 1. If I put the 3 here, what's the absolute value of 3? 3 and half of 3 is 1.5. Go ahead and write the domain before we even graph it. What's the domain for all of these absolute values? Negative infinity to positive infinity every time. Now we need to plot those points. So -3 goes up 1.5 units. -2 goes up 1 unit. -1 goes up halfway. Then we have 0, 0. 1 goes up halfway. 2 goes up to 1. And 3 goes up 1.5. And if we do the math correctly and plot the points correctly, it will make a V. And make sure you put your arrow showing it keeps going up. And what does range mean? The y value. So if you look at your vertex right here, what's the y value of the vertex? 0, and the y values go all the way up to infinity. Which one goes first? 0, comma, infinity. Do I have a point at 0? Yes, a 0 gets a square bracket. Can I have a point at infinity? No, so infinity gets a parenthesis. And they ask us, how does this one change compared to the parent function? Did the vertex move? No, but instead of going up 1, how much does it go up? A half. So this is called a shrink. So this one shrinks by a factor of 1/2. So this one is a shrink by a factor of 1/2. So make sure if you say the structure shrink, you say what was the factor it was multiplied by. So this one was shrunk by a factor of 1/2. And we have one more to go. Okay, so let's look at the last one. If you notice, what number is right here in front of the absolute value? -1. So absolute value first, and then multiply it by -1. So if I put a -3, so this would be a negative out front, and a -3 inside. So grouping symbol first. What's the absolute value of -3? 3. And what's -1 times 3? -3. If I get the next one, we'll have a negative, and then a -2. Grouping symbol first. So what is the absolute value of -2? 2. And 2 times -1? -2. The next one, if I put a -1, what's the absolute value of -1? 1. And 1 times -1? -1. If I put a 0, what's the absolute value of 0? 0. And 0 times -1 is 0. What's the absolute value of 1? And 1 times -1? -1. What's the absolute value of 2? And 2 times -1? -2. If I put in a 3, what is the absolute value of 3? And 3 times -1? -3. Go ahead and write the domain. What's the domain for all absolute values?
Negative infinity to positive.
Negative infinity to positive infinity. Plot your point.
Is it always going to be that?
It's always negative infinity to positive infinity for every absolute value function. Negative 2, negative 1, 0, 0, 1, negative 1, 2, negative 2, 3, negative 3. And this time, instead of pointing up, which way does it point?
Down.
Down. So this time, put arrow showing it's going down. Yes, it flips. Now, we'll have to be careful when you write the range. So when you write the range and it points down, you're going to have to be careful. Because if I look at the vertex, what's the y value up here at the top? 0, and it goes all the way down to, this is not infinity, what's down here at the bottom?
Negative.
Underbound.
Negative infinity. Now when I write these, it needs to be least to greatest, so be careful. Which one is the smaller number?
Negative
0 or
infinity.
negative infinity?
Negative infinity.
Negative infinity, so this needs to be negative infinity, comma 0. Can I touch negative infinity? No, so it gets a parenthesis. Do I have a point at 0? Yes. So 0 gets a square bracket. Now to describe the change, how does this one look different from the parent function?
Flipped over the x.
It reflected over the x-axis. If you said flip, that's fine. But the mathematical term is that it reflects over the x-axis. So it reflects over the x-axis.